So now that we've dealt with how to graph quadratic equations and talk about the domain and range and all of those pieces, we're actually going to deal with how to solve those based on the graphs themselves. And so we're going to determine the roots of a quadratic equation by graphing, and then we're going to write equations for quadratic functions given those roots. Okay, so when you have this first term called roots, this is where the quadratic equation crosses the x-axis. So there are a lot of other names that roots go by: solutions or answers, zeros, and x-intercepts. All three of these things are interchangeable with roots. So it's really, 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 really important that you know all of these, because they are going to switch them out on you constantly, and you have to know what it is that it's asking you for. So if we're looking at these graphs right here, we're looking for our intercepts. So where do these things cross the x-axis, not the y-axis? So as you're looking at those, you'll notice that this first one hits once. So it has one real solution. It hits here twice, so two real solutions. And then it doesn't hit at all, so it doesn't have any real solutions. So I want you to make just a quick general sketch of what these look like, because these are the three types of roots that you may have given a graph of a quadratic function. So what we're going to do is practice with finding the roots. This is really easy. You're just going to write them down. So if we're given the graph here for number 1, they give you the equation. Here's the graph. And we have our roots. So right here and right here. So the two roots that we get based on this graph would be x equals -1 and x equals a +1. And that's it for that. Now for number 2, we're looking at where it crosses the x-axis, not the y. But it doesn't cross at all, so we would say no real roots. And you could say solutions, zeros, anything like that. It's all the same. Okay, so now I'm going to give you these zeros, and we're going to talk about how to find the equation. So it's really easy if you follow the same steps every single time. So if I start with this first equation right here, x equals -2, what I need to do is get these set equal to 0. So you want to have them in the form x minus p times x minus q. And remember that from our intercept form from the last lesson that we did, right? So we need the p to be on the same side of the equation as the x, which means we need to have x minus p equals 0. Now the sign here doesn't matter. All that matters is that we get our number and our variable on the same side of the equation. So I'm going to add 2 to both sides to get x plus 2 equals 0. So that would mean x plus 2 would correspond with this section of our equation right there. Now our x equals 4/3. What I'm going to do is actually start with multiplying by 3 to begin with. So I get 3x equals 4, and then I'm going to subtract 4 from both sides to get 3x minus 4 equals 0. And so then we get our factor of 3x minus 4. And so when we write our answer for this, we'd write f of x equals, and I'm going to put this a here because we don't know what that a term is, but x plus 2 times 3x minus 4. And so that would be your final answer for your equation here. So get your number on the same side as the x. Now I'm going to show you a second route on how to deal with this x equals 4/3. So what you could do instead is subtract 4/3 from both sides of your equation. So we end up with x minus 4/3 equals 0. Then what we do is this little method called the slip and slide, where we're going to take the 3 here and move it up in front of the x and make the 4 a whole number. So it would become 3x minus 4. So these are the same thing, but it's a matter of, will you remember the slip and slide or not? You know, it's entirely up to you. These 3's cancel on this side, and then you just subtract the 4 or go this route. It's whatever you feel more comfortable with. So just 1 or 2 more examples, pretty quick. Now this thing right here, this x equals 5, you'll notice that there's only one solution. So what that means is that this actually is considered a double root. Or we also use the term multiplicity of 2, because we have to have 2 roots every single time for these types of equations. We have to. And so since we only have the 1, what we need to do is double it up. So we're going to write x equals 5, and then we're going to write x equals 5 a second time. So get your number on the same side of the equation to get x minus 5 equals 0, giving you x minus 5 as a factor. Subtract 5 again, then to give you x minus 5 equals 0, giving you x minus 5 is a factor. So your final solution would be f of x equals, I'm going to put my a in here because we don't know what it is, times x minus 5 times x minus 5. Now, one extra step you can do in order to write this the exact same way but more simplified would be to write x minus 5 squared. These are the same thing. And so one thing I actually want you to come back and write is that this is called a factor as well as this. These are both factors. Okay, so that way if we were to actually graph this thing, it would just kind of hit the graph and then bounce right up off of it. Okay, and then one more example, and this one I want to show you because it's x equals 0, and people kind of panic with that. So when we write x equals 0, we could add or subtract 0 or whatever and get x minus 0 equals 0, but it's still just x equals 0, right? So that means the factor is just x. There's nothing else to it. So we don't even need to do any of that. All we have to do is from this point right here, it's just going to be x. And then we have x equals 9. So we can subtract 9 from both sides to get x minus 9 equals 0. And so then our factor is x minus 9. So when we go to write our f of x, we are going to put our a, and then we're going to put x here, and then x minus 9 right next to it. So sometimes you may see something like a number times x, and then x minus something or plus something afterwards. And so this thing is also part of the 0 itself. Okay, so make sure you have all those down. Come ready with questions and ready to do some graphs and work with some of these zeros and writing these equations, and hopefully you will be good to go.